Okay, so far we have in this lecture we have considered how the state of a quantum system evolves, and we've said the way it evolves is through a rotation of the Hilbert space, a unitary rotation, which is of course a linear transformation. So now we are going to study a very interesting consequence of this linearity, which is called the no-cloning theorem. What it says is that if I give you an unknown quantum state, so if I give you a qubit which is in an unknown state, then you cannot make a copy of it. You cannot create two qubits in exactly that same state. Okay, so before we study this, let's first consider what happens if you have a two-qubit system. So if you have a two-qubit system, its state is, well, it's a unit vector in a four-dimensional complex vector space. And so the unitary evolution axiom tells us that the way the state evolves is by a rotation of this four-dimensional complex vector space. So it's given by some unitary transformation, which is now, U is now a 4x4 unitary matrix. So it's a complex matrix which is 4x4, so it has 16 complex numbers in it. And the fact that it's unitary is given by the fact that U times U dagger is the same as U dagger times U is the identity. And of course U is a linear transformation, which means that if U of psi 1 equal to phi 1 and U of psi 2 equal to phi 2, then U of psi 1 plus psi 2. Okay, so let's write it like this. So suppose psi equal to psi 1 plus psi 2, then U psi equal to, so if you apply, if the state psi is a sum of two, psi 1 and psi 2, then when you apply U to psi, you get phi 1 plus phi 2, right? Added as vectors. So that's just linearity. So now let's try to understand what it would mean to copy or clone a quantum bit. So imagine now that you're given an unknown quantum bit. So it's in some state psi which you don't happen to know. So let's say psi was A0 plus B1, where A, B are complex numbers and you don't know what A and B are. But what you want to do is you want to somehow create a copy of this bit. So you start with a clean qubit, it's in the state 0, and now you want to do some transformation to these two qubits so that you end up with both qubits in the state psi. So what's your output state? Well, the output state should be, well, A0 plus B1, that's the state of the first qubit, and then A0 plus B1, that's the state of the second qubit. So our output should be A squared 0, 0 plus AB 0, 1 plus BA, which is AB 1, 0 plus B squared 1, 1. So this is what our output should look like. Now let's look at a few cases. So what happens if the input, what happens if psi was equal to 0? What should our output look like? Well, of course, in this case, the output should be, of course, 0, 0, because we want each of the two qubits to look like 0. On the other hand, if psi was equal to 1, then the output should be 1, 1. right? Because we should copy this 1 over into the other qubit. So now by linearity, when psi equal to A0 plus B1, what should the output be? Well, the output should be A00 plus B11, because it should be A times whatever it was in this case plus B times whatever it was in this case, and that's this. So now, if we do have such a copying circuit, then this must equal to this. But how can these two be equal? Well, the only way they can be equal is if A times B equal to 0. But if A times B is 0, then either A equal to 0 or B equal to 0. Meaning that our initial qubit must have been either the 0 qubit or the 1 qubit. Okay, so that says that if you achieve a copying circuit, if you can clone a quantum bit, and if you can clone it both in the case it happens to be in the 0 state and in the 1 state, then there's no other state that you can possibly clone. Right? The fact that you manage to copy 0 and 1 prevents you from copying any other state. Okay, so this is, the no cloning theorem, which says that it's impossible to clone an unknown quantum state. In fact, it even says something much stronger. What it says is that if your unknown quantum state, if you don't know whether, if there are only two possibilities for psi, so you know that psi is one of these two states. It's either in the state 0 or it's in this state which is not orthogonal to 0. It's some A0 plus B1 where A and B are not equal to 0. So if you know that psi is one of these two particular states where you know A and B, then you cannot clone this quantum state. So you cannot make copies of psi. There's no way to transform psi and 0. There's no way to transform the first qubit in state psi, second qubit in state 0. There's no way to transform this into first qubit in state psi, second qubit in state psi. That's the no cloning theorem.